All right, so we got a couple more up here. And that first one, you got f prime of x equals 3 over x squared plus square root of x. You're also given this other thing, f of 1 equals 0. We'll talk about that at the end. That's called an initial condition. Get there in a minute. But for starters, let's just kind of find our general f of x here from this. Maybe I should leave room for an intermediate step. What do I maybe want to do to f prime of x first? Lauren? Yeah, exactly. We want to rewrite it as power functions. We just learned that power rule, right? That power rule works for more than just positive integer powers. So exactly, we want to write it as power functions, and now we can use that power rule. And good. So somebody want to tell me what you got for f of x then? You got it, Jake?
Negative 3x to the negative 1 plus 2/3 x to the 3 halves.
What do you guys think? Does that look pretty good? Looks good to me. There's one thing though. Plus c. I heard about one calc teacher getting temporary tattoos made of plus c, and I think it's great. I think we should get them in red, and it'd be like the scarlet letter. Like if you forget it, we'll just put it right on your forehead. Although that wouldn't help you because you wouldn't see it, but everybody else would. So I don't know. Anyway, yeah, that sucks if on the first like integral quiz when we get there, if somebody just forgets that all the way through. I don't know. Well, I'll probably remind you, but you don't want to forget it. It is important. But you know, we're just learning it right now. Anyway, yeah, that's right. This is called the general antiderivative right here. And the reason it's a general antiderivative is because it has the plus c. It has this unspecified constant of integration, right? So it's actually a lot of different functions, right? And if you think about it, it's like f of x. If you think of this f of x, plus c lets you shift that function up and down vertically as far as you want, right? Would that change its derivative if you shift a function vertically? Does that change the slopes of the tangent lines? No. So that's why that works. This is called the general antiderivative, and it has the constant of integration in it, right? But sometimes, in some circumstances, in some contexts, we can actually solve for c. Okay, and this is that context because we are given what's called an initial condition. So if you weren't sure what to do with that before, this is where we use it. Once you get that general antiderivative, you just plug it in and you solve for c, and then you can write what's called the particular solution or the particular antiderivative. Okay? So go ahead and plug it in. If I plug in 0 for y, 1 for x, x to the negative 1, so it's like 1 over 1, right? 1 to any power is just 1, right? And so negative 3, that's negative 9/3, plus 2 is negative 7/3, yeah? So add it to the other side, c equals 7/3. And so now my final answer here, f of x equals, and I'll kind of rewrite it. You could leave it like this though. The power function format is fine. I mean, you want to plug in c, but like you don't have to do what I'm going to do with the x's here. But I'll rewrite it as negative 3 over x plus, and 2/3 x to the 3 halves is fine. But again, I think it's good to just keep in mind what that means. I want to make sure you understand what all these powers mean. And then plus c, so plus 7/3. This is my particular solution. Okay, so a bit of vocab here. Okay, those are all terms you want to know. Initial condition, general solution or general antiderivative, constant of integration, and particular solution. We're going to do the same thing on h here, or h prime, whatever. We're going to find h. We are given an initial condition. We're going to find the particular solution for h. And I think you guys did that one already too, yes? Maybe not the particular solution yet. So we'll talk through that. I do want to show you one more thing, as long as we're learning some vocab here. I'm going to show you a notation. So we could just write h of x equals, but on the front cover of your textbook, there's this big old blue symbol. I don't know if you've really paid attention to it before, and that's an integral symbol. And this is how you signify that we're going to do an integral or an antiderivative, which are, we'll talk a little more about the distinction there, but I will just say an antiderivative is an indefinite integral. There's also something called a definite integral. We'll talk about that very soon too. Anyway, h of x is the antiderivative of h prime of x, and then you need dx here, which means with respect to x. It's like the dx and dy dx. Again, these are things we'll talk more about later, but for right now, I feel like we can see the symbol, the notation there, and it's useful. So you could kind of think of those two things, that integral symbol and the dx, which is called the differential. You could think of those as like bookends that tell you that you're going to do the antiderivative to what's inside here. This is called the integrand. Just like the inside of a square root is called the radicand, because it's inside of a radical. This is inside of an integral. It's called the integrand. Okay? And yeah, so you already know what to do with it. You probably already did it. What's my antiderivative for sine of x? What do you think? What do you got there? Do you have it, Sydney? It is negative cosine of x, yeah. Yep, because the derivative of cosine of x is negative sine of x, right? Cool. And then, what about the plus 2 over x? Did you guys get stuck there trying to do the power rule and dividing by 0? Yeah, that's a red flag. If you're dividing by 0 using the power rule, let that red flag go off, and remember what we're about to say here. So when you're doing this, when you figured out the antiderivative of sine of x, you probably asked yourself, what is sine of x the derivative of? Yeah? Like that's how we're figuring out these, because you already know them. You already know your derivative rules, so we're just doing them backwards now. Ask yourself the same question now. Forget about the 2, it's just a constant multiple. What is 1 over x a derivative of? The natural log of x. One more thing on that in a sec. As soon as the announcement's over. All right. So there is one issue with that, but that is right. So I missed the 2. That's one issue. That wasn't the one I was talking about, right? The constant multiple stays, right? So like, just think about this. If you were taking the derivative of 2 times natural log of x, you do 2 times 1 over x, right? You get 2 over x, right? So that works. However, there's one little detail on this that we've mentioned before. I don't know if you'll catch it. Anybody know what it is? Absolute value of x. It's the natural log of the absolute value of x. That's right. And the reason is, and I'll talk more about this another day. I don't want to get too bogged down in this right now, but we've talked about it before. But basically, the thing we started with was the 2 over x. And the domain of 2 over x is all real numbers except 0, right? If we don't put the absolute value here, we are restricting that domain to only positive values, and that's just not fair, right? The 2 over x had negative values included, so we should have them here as well. And it works with the absolute value there. That relationship holds through. So we don't want to restrict the domain as we go through a problem unnecessarily. So we have the absolute values there. You do need them on your antiderivative rule. Again, I'll talk more about that in detail another day, and like with derivatives and antiderivatives, when you need it, when you don't, all that stuff. But yes, when you're doing antiderivatives with this form, you absolutely need to put it. Good. And then one more thing. Plus c, the constant of integration. So there is my general antiderivative. And then we want to find the particular solution by plugging in pi for x and 0 for y for h. Negative cosine of pi. Cosine of pi is negative 1, right? So that'll be positive 1 plus 2 times the natural log of the absolute value of pi, 2 natural log of pi, and plus c. There's not really much to do with that natural log of pi. It is what it is. So when we solve for c, we're just going to get c equals, negative 2 natural log of pi minus 1. And plug that into our function. We get h of x equals negative cosine of x plus 2 natural log of the absolute value of x plus c. So minus 2 natural log of pi minus 1. Good? That's it. All right, we're going to practice some problems out of the textbook now, and we can go to the boards for this if you like. This is something where you just need to get some repetitions in. So kind of get the hang of it, start to see things.